All right, so today we're looking at similarity specifically in right triangles. So we looked at similarity in general the other day, right? Where things can be in proportion to each other if they're similar figures, right? What did I tell you guys makes two figures similar? So those were like the last four problems on that worksheet you just did. What are the ways that figures can be similar? What do you have to know? What's true about their angles? Any angles in a similar figure should be Ifta, guys. Okay, so remember that we knew that corresponding angles in similar figures should be congruent, right? Notice that what I have here is a big right triangle, right? This big right triangle. And what I've done is I've cut it into two more right triangles, this little kind of medium guy and the really small guy. The question is, are these similar? All right, let's take a look really fast to see if they would have the same angle measures. I'm going to give you a specific case so that you can kind of think through it. Let's say that this is 40 degrees down here, okay? What is this angle measure right here? Oops, that's a 90, yep. What is this little angle measure right here?
That would have to be
50, right? Because in a right triangle, this is a right triangle, these two need to add up to 90. We've been doing that for a while now. So this angle has to be 50. All right, what does this angle measure have to be? Think of the big triangle. Look at the big triangle, right? Pretend like this line weren't even here. Then what would the two acute angles of the big one have to add up to?
90.
They have to add up to 90, which means this has to be 50 again, right? What is this little angle right here? 40. This sequence will always happen, even if this wasn't 40 degrees and I made it something else, it would still happen that this angle right here would always be congruent to this angle right here. That doesn't have to be 40s, right? That's just kind of what worked out. I just gave you a specific example. The main thing to take away, though, is that these two angles are equal. Same thing is going to happen here. This 50-degree angle is always going to be equal to this 50-degree angle, or whatever degrees it is. It's not necessarily 50, but whatever they are, they're going to end up being the same. So are these triangles all similar? Yeah, right? All right, so that means that I can use proportions to solve missing pieces. So here's what I'm going to do. I'm going to put some information around here. So let's say that I could tell you that this side right here is 5, this guy right here is x, and this guy right here is 4. And I want you to find x. Notice that you can't use Pythagorean theorem, right? Because this triangle right here, you don't know the hypotenuse, so you wouldn't be able to use Pythagorean theorem. Same thing with the little triangle. Do you know what the angle measures are? No. I just did that 40 and 50 to help you see that these things were equal, but I wasn't necessarily saying that they are 40 and 50. So do you know what these angle measures are? You just know what's the same, but you don't know what they are. So you can't use 30, 60, 90, and you also can't use trigonometry without knowing an angle measure, okay? You're going to have to use similarity. Now, it's hard to look at the figure like this, so what we're going to do is draw 3 triangles off to the side. So we're going to draw a large right triangle off to the side, a medium right triangle, and a small right triangle, because that's what we've got. We've got a large, a medium, and a small, right? Okay. Make sure you mark your right angle so you can see where these things are, right? Now keep in mind that they should all be oriented so that their single angle is at the top, the double angle is at the bottom, and that's what allows these to all be similar. Okay, notice that I have put them all in the same orientation. So I've drawn them all with the short side on the bottom, the medium side up the top, and then the hypotenuse side down this way, right? It doesn't matter that you orient them exactly like this, as long as once you draw one orientation, you draw the rest exactly the same. Okay, the reason why I've done that is so that I can pick out my matching sides, right? So when I am doing this, looking at the large triangle, remember, is the overall big guy around the outside, like this. Do you know the short side of that large triangle? Do you know the short side? No, right? Do you know the medium side of that? No. Do you know the hypotenuse of that big triangle? What is it? 9. So you would fill that into this figure as being something that you know about that triangle. Okay? Take a look at the medium triangle. In your figure, you can see that this right here is your medium triangle. Okay? So what is your short side on that medium triangle? X is your short side. Do you know your long side? Do you know this side? Yeah, that's 5. The biggest mistake here is that some of you guys are going to mix up what's the hypotenuse and what's the long side. So make sure that you're really being careful about which one is your hypotenuse and which one's a long side, okay? That's 5 on our long side. Okay, on the small triangle, do you know your short side?
4.
4 is the short side. Do you know your long side? Long side is X. Do you know the hypotenuse?
No.
No. So what's going to happen is what you need are 2 triangles that have 2 pieces of information each that match. So in other words, on these 2 triangles right here, we know both the long side and the short side, right? So these are going to be what I'm looking at. I'm actually going to completely ignore from here on out this triangle because it didn't give me enough information. Between these 2, can you use what we did last week to set up some similar fractions? Okay, what would be an example of a similar fraction I could set up? 5 is to x as x is to 4. Very good. So you could have done that going 5 is to x as x is to 4, or you could have done 5 is to x as x is to 4, right? As long as you pick a pattern and stay with it. Okay, now we cross multiply. So if I cross this way, I get x squared equals 20. To solve this, I'm going to take the square root of both sides. So x is going to equal the square root of 20, but can I simplify that? Is there a perfect square that comes out of that? What's the perfect square that divides 20? What? 4. And when you square root 4, what does it become? Square root 4, what does it become? 2. So if I remove the 4 out of there and square root it, I'm pulling it as a 2. What's left once I take 4 out of 20? 5 is left. Okay? So this would be my answer. Let's look at one more example. All right, so for this example, I've given you different pieces. Last time I gave you both of these 2 little pieces, and then I gave you this piece right here, right? So I've given you a different combination. Do you think I'm going to go about this any differently, though? No. I'm still going to draw out my 3 triangles, figure out what my pieces are, find the 2 triangles where I know 2 pieces of information, and use them, okay? So let's draw out our triangles. I've got a large triangle that I can work with. Medium. And small. Need to fill in the pieces I know. So when I'm looking at the large triangle, do I know the short side? Do I know the medium side? That's 9, right? Do I know the hypotenuse? What's the hypotenuse? Good. All right, for the medium triangle, so that's going to be this little dude right here, right? Do I know the short side?
Yes.
I do.
That's not the short side, though.
Of the medium triangle, it sure is.
Oh, I thought it was hypotenuse.
Nope. So I don't know the short side. Do I know the medium side? There's nothing I could put for that? Nothing at all? And I should. If I can, I should put it. So yeah, do you guys see how this is 10 minus x for that? Because it's taking this piece right here, would be taking the full 10 and subtracting off that x, right? Not of the medium triangle. On the medium triangle, this is the long side, because 9 is the hypotenuse across from the right angle, right? So 9, oops, I'm sorry. Did I write it on the hypotenuse? I did. So I did put it on the wrong side. Sorry. So that should actually be right here. 10 minus x. And then the 9 should be the hypotenuse, right? All right. For the small triangle, do you know the short side?
Yeah.
Yeah. Do you know anything else about that one?
No.
And is there any way for you to come up with like similar, like is there anything to write for this?
No.
In this? No. Notice that had I not done this piece right here, I would have been short of information because I need two triangles with two pieces of matching information. Without this, I wouldn't have had it, right? So which triangle am I going to ignore right now?
This last one.
The small one. So now I can set up similar fractions. So let's say that I do 10 is to 9 in this triangle. So 10 is to 9. What would be the matching setup for the other triangle? 9 is to 10, or 9 is to 10 minus x, yep. All right, so I need to cross multiply on this and solve it. So remember that when you cross multiply, first of all, I'm going to have 81. Well, I'll do this one first, actually. So let's do the 10 times the 10 minus x. Remember that this 10 right here needs to multiply to all of this. So what is it going to multiply to? 100 minus 10x. Very good. And that's going to equal 81. Okay. So when I subtract this 81 or 100 off of 81, I'm left with negative 19 over here. So that's negative 10x equals negative 19. If you divide by 10, what do you get? It's going to become positives, right? Because two negatives will make a positive. So what's 19 divided by 10? 1.9, right? That's actually a pretty nice decimal. You could leave it as 19/10 and that would be okay as well. Any questions on how to deal with these problems?